Okay, so hi everyone, or should I say Kalispera here. So my name is Rémi, I come from France, and maybe you already guessed that from my accent. And today I would like to talk to you about ZK and identities, because actually many applications need to verify the identity of the user online. And today that's quite hard, because they are stuck between the centralized KYC solutions and other technologies such as WorldCoin, which need to spread their technology worldwide. So fortunately, the International Civil Aviation Organization has built a great tool that we can piggyback on, which is the electronic passports. Those documents are currently issued in more than 172 countries, and they contain a bunch of data about you, which is signed inside an NFC chip inside the documents, such as the name, surname, birth dates, and so on. So if you got this logo over your passport, this means that you got an electronic one. Anyway, I think you understood where we are going at. So let me introduce you Proof of Passport, which is a mobile application who lets you scan your passport and to generate some ZK proof on top of it. So why ZK and Passport? Because by combining those two technologies, we can currently answer to different issues related to identity. The first one is obviously the civil resistance. How to prove that it's a human who's behind an action, which is, in my opinion, crucial for actions such as voting, collateral fundings, to help social media to get rid of bots, or yeah, I think that's most of it. We got also the selective disclosure. Maybe you want to disclose something very specific about yourself, but you don't want to share any other personal information. For example, countries forbid the people to buy alcohol or either to play on casino online under the age of 18 or 21. And I think ZK could bring more privacy into that. And the last one is that some passports actually host private keys which can sign data. And this is really interesting for active authentication, which can lead us to features such as wallet recovery or signing transaction. So a signing transaction in a context such as for a small amount or either in a multi-sig wallet. However, there is some limitation about the passports. Of course, for the moment, we don't know if a passport has been borrowed or stolen. Also, the countries which the passports got the private keys, so they can forge as much as passport as they want to. And finally, maybe some of you tonight have a dual citizenship, and if it's the case, you may actually own more than one passport. So before going any further, I would like to thank PSC and the Ethereum Foundation for the grants and to tell you that the project is fully open source. So let's get back into it with a demo of the mobile application, so you will have a better idea of what we are currently achieving. So the first step is to take your phone and to scan the passport with the camera. Then you put it on your document open flat, so it can dialogue with the embedded NFC chip. And mind that at this point, everything is achieved locally, so no data will be shared with external applications. Next, just select the application you want to generate the ZK proof for. In our case, we will go for the soundbound token. And finally, just enter your Ethereum address and select some additional information about yourself that you may want to disclose. So let's click on the Generate Proof button. The proof is generated, and in our case, so this is what actually look like the soundbound token over OpenSea. You can see that I have disclosed that I am over 18 years old, which is something that you may have already guessed. But yeah, we unfortunately don't have a great picture. We need to improve this. Okay, so let's bother you a bit with an official document of what you got inside the different data groups. So the first one is the traditional data about yourself. So you got name, surname, nationality, date of birth. So what we have done is that we have currently implemented a range check over it. So as you saw in the second token, you can actually prove that you are older than a certain age without even revealing your birth date. You got your gender also. Your pictures is also signed, which is cool because because it means that we could actually achieve some ZK ML to do face matching over it. And you got also optional data group, such as the one I mentioned before about the actual authentication to let the passport sign a given message. Okay, so I think we can take a look to how the proof is currently generated inside the application. So this is our simplified version of our ZK circuits. For those of you who are not so familiar with this, keep in mind that it's just a visual representation of the arithmetic circuit which is inside the application. So what we basically do is that we take the different data group as inputs, we hash them together, we concatenate the hash, then we hash it again, and finally we format this final hash and hash it one more time, and then it is signed by the issuer country. And this is the place where we can actually verify the signature. The little twist here is that this final hash and the signature function will change upon the country you are from. So this leads us to a serious trade-off, because as we are currently using Go16 and Circom as a tech stack, our proving time is proportional to the size of the circuit. So on one hand, the thing is that we could have one big circuit with every hash and sync function inside of it, but the user experience will be totally damaged. And on the other hand, if we decide to have one setup or one circuit for each setup, it means one verifier too, and so it will not leak directly the country you are from, but it will leak a kind of group of country which is using this hash and SIG setup. So this is a simplified version because actually we have more inputs, such as a bitmap, which is just a list of 1 and 0. So you can select the disclosure, and the bitmap would be basically just multiplied to the outputs to give the final output. We don't want the public key as a public input. Instead of it, we will provide Merkle routes, and the different public keys of the issuer country will be stored in a Merkle trees. And what we want the user to do is to generate a proof that the pub key who signed its passport belongs to the Merkle tree. We will also have some additional features, some additional inputs related to additional features, such as the age you want to prove that you are older than, or the current date to make the run check. So this is what our endgame circuits actually look like. So at this point, keep in mind that it's purely speculative. However, there is a nullifier module, which is really interesting because we don't want people to use the same passport to generate multiple proof. So yeah, that's kind of an alpha, but for the moment, it's speculative. For the current circuits, we have around 432 constraints. And yeah, and I think that's it for the circuits. Yes, if you want to, currently with the Subon token, we verify the proof on chain. To do this, we just deploy a verifier contract. And on the main function of the Subon token, we will also verify the Merkle routes of the registry with all the public keys, and also the current date, which is an input, that we will compare to the block timestamp. So let's zoom out a bit and see how the different modules are integrated into the application. So as you can see, we are currently using React Native with different modules for reading the passport, either it be for the camera scanning or NFC scanning. And we are using a bridge to the proving library RapidSnark. And to give you an idea, currently on iOS, we have a proving time which is around 4 seconds with an iPhone 15. So all of this is great, but you may ask yourself if you can use proof of passport actually. So this diagram shows in green every country who is currently issuing an e-passport. So see this as the potential of the application. And if your country is not in green, don't worry, there is maybe another project such as another for India, which is addressing the local identity documents. But as I said before, the last hash and sync function will depend upon the country. So for the moment, we are supporting the SHA-256 with RSA encryption, and the SHA-1 function is also under development. The next security we want to include is ECDSA, SHA-512, and SHA-384. But the little trick with that is that we don't personally own passports with such signature algorithm, so it's quite hard for us to test it. So try the app, which is in open beta right now on iOS. Check if it works with your passport, and if you don't, reach us. And you can contribute. You can also contribute easily to the project and make your country supported by a proof of passport. If you do so, we have currently a bounty program over it. And on the right here, you will have the QR code to access to the open beta on TestFlight on iOS. And on the left, you have the QR code leading to the landing page, where all the information will be gathered. Okay, so I think that's it for this talk. Thank you again for the opportunity to talk about the project. Thank you for your time and for your attention. And if you have any question, I would be glad to answer to it. Yes, please.
Why does the country count as the last hash? What is the reason for this?
I don't know. Actually, I don't know why they do this. But I know that in the specification of the ICAO, who decided the specification of the e-passport, like the country has the choice between different hash and sync function. So actually, they just do what they want for this. Yes, please.
Nice talk, by the way.
Thank you.
I'm curious, like, first part that you mentioned about having stolen or borrowed passport. Is there a registry maintained by them that sort of says that these passports are just stolen and borrowed?
I don't know. I don't think so actually. But this is a great point because the document number is actually signed. So if it exists, we could actually shoot those kind of passports. But I don't think there is actually like an open repository with the stolen passports. If it's your question.
Yeah,
Actually, the stolen passport are like, it's a private database, speech support, emergency.
oh, right.
Yeah.
Yeah, thank you too. Yes.
So if you were to use this proof of passport in an application, and you wanted to nullify, so you only want one user per passport in that system. If you wanted to do a nullifier on this, would that leak information across? Like someone who's able to see, someone knows some information about you, are they able to work it backwards?
Okay, so is your question like if I got every information about your passport, should I be able to forge a proof again or at least to forge the nullifier? to match you back between your identity and your real life identity and your ZK identity.
Like how do you anonymize the nullifier?
Yeah, okay. The nullifier is a real problem about this. That's a really great question. We are really thinking about this because actually we don't even know if the countries they stock the data about your passport. So it's kind of hard to generate a nullifier knowing that maybe they have exactly the same data that you have. So currently there is my co-founder Florent who did a post about this, and we can imagine some like of third-party operation with like a server who could generate a nullifier for you. But the problem is that if the government has all the information about your passport and if the government requests actually the database of the server, it may be complicated. So what we are thinking about is really to focus about the active authentication that you may have inside your passport. I think this is actually the best way to achieve it. But you're right, this is a great question.
Sweet. All right, cool. Let's give Rémi a final round of applause. And,